Er ist auch von der Physikalisch-Technischen Bundesanstalt, von der PTB hier in Braunschweig. Er ist hier Doktorand und es geht um Widerstand, denn nein, er ist nicht immer zwecklos, aber er kann sogar ganz genau bestimmt werden. Quantum Hall Resistance in Our Life. And he is doing his presentation in English. Please, a warm welcome here on stage. Good to have you here. Yefei Yin! You got your...
Hello, everyone. Good evening. I'm Yefei Yin. It's my great honor to be here because last is not the least. So today, I will tell you the story about the quantum Hall resistance standard for our life. So nowadays, we have a lot of electronic devices. For example, laptop, tablet, and smartphone. And if we open the backside of this electronics, we will find a circuit board. On the circuit board, there are a lot of resistors. The resistor is the basic component for this electronics. Do you think about how do we measure the resistance of resistor? Here is the Ohm's law. As we know, if we have battery and we have bulb, when we close the loop, then the bulb will be lightened by the battery. The bulb is the resistance. The flow of electron is the current, and the battery is the voltage. And then the voltage equal to current multiply resistance. This is the resistance. There is a guy named Amp. They want to go through the tunnel, but there is a bad guy named Ohm. They try his best to block this tunnel and resist Amp go through the tunnel. So do you recognize this is the exact situation in our working place? Here, Amp maybe is you or your colleagues, and volt is your colleagues. I won't tell you who is the Amp, Ohm, because my boss is sit over there. Okay. According to the Ohm's law, the engineer developed the multimeter. By the multimeter, we can measure the resistance. For example, here is the 100 ohm resistor. By this multimeter, we can measure the value of resistance. But have you think about if we want to measure the resistance with 9 digits, how can we do that? 9 digits means the accuracy is on the scale of nano-ohm. The multimeter is unable to reach such a high accuracy. Let's think about the question from the easiest way. When we are young, every mom would like to make a mark on the wall and measure the height by the ruler. The ruler can easily distinguish the small difference of the height. So, for the resistor, we need a similar ruler. This is the old ruler of the resistance. The 100 ohm resist made by wire. This is the wire resistor. And this resistor can calibrate the other resistors precisely. However, this is the result from this 100 ohm resistor from 2002 to 2007. The scientists found the value of this resistor is slowly goes up as time going by. You see, there is a difference. There is a difference on 2007 and 2002. So you can imagine the scientist is unhappy for that because it's unstable and it's not reliable. So, how can we get an ideal ruler of the resistance, which has high accuracy, up to 9 digits, and has no variation over years? Klaus von Lissing, he is a German physicist and the Nobel Prize winner. He found the quantum Hall effect and the quantum Hall resistance. Klaus von Lissing, here is the Hall bar device. Klaus von Lissing, he applied a current on the device and measure the voltage on these 2 pairs. And the voltage divide the current. He calculate the resistance Rk. When he apply a magnetic field in this device, he found the Rk is a constant. And the value is about 25,812 ohm. This is a universal constant. We call this is the quantum Hall resistance. Because Klaus von Lissing found this resistance, we call this is the Lissing constant. So the quantum Hall resistance is a constant value, therefore is an ideal and a perfect ruler for a resistor, which has temporal invariance and spatial invariance. The temporal invariance means no matter we measure last year, this year, or next year, we always get a same value. The spatial invariance means no matter we measure this device in Berlin or in New York or in Shanghai, we still get the same value with high accuracy. This is the old ruler of resistance. Before 1990, the resistance standard, the wire resistor is the resistance standard, but it's unstable. So nowadays, we don't use it anymore. This is the quantum Hall resistance standard. So this is the real device we made at our lab in PTB. So now this device is the resistance standard in Germany. Every half year, my colleagues will measure the resistance from this device. And to confirm the resistance value is constant. And then he will write a report to the government to announce this resistance is a reliable and a stable resistance standard for our life. Here is the calibration chain to show how the PTB standard influences our life. So the quantum Hall resistance is a resistance standard. This is the goal of resistor because the other resistance need to calibrate by this one. So we have the standard resistance from PTB, and the other resistance need to calibrate with this one. For example, the reference standard from the calibration laboratory or from the company, they need to compare with the one at PTB. And then they use their standard reference, calibrate their test equipment. And by this test equipment, they calibrate the multimeter. And finally, the multimeter can measure the resistance precisely in our life. That's the story about quantum Hall resistance in our life. I hope you like this story and have a nice evening.
Vielen, vielen Dank. Yefei Yin, dein Applaus, your applause. Thank you so much.